Well, hello everyone. Welcome to lesson 5.9. I'm sorry I wasn't there today, but I hope you liked this video, so thanks for tuning in. So today we're talking about powers of products and of quotients, meaning that we are going to take things that are already products or quotients. Products are things that are multiplied, quotients are things that are divided, and we're going to take them to a power. We're going to raise them to an exponent. So what we're talking about are in the purple things like these examples. Okay, so let's start this off with the rules for what we do when we're trying to take the power of a bunch of things that are either multiplied together or are divided. Okay, so the rules. First of all, if we are doing a product, the general rule is if I have any two things that are multiplied together in parentheses, and we'll talk a lot about the parentheses in this lesson, what I basically do is I take the nth power of everything that's in the parentheses. So in this case, I'm going to take a to the n and b to the n. Okay, so here's an example. So that example from the front slide where I had 3ab squared all raised to the third power. All three things, 3a and b squared, are in the parentheses, so all three of them get cubed. You could think of this kind of like the exponent version of the distributive law. Okay, so when I expand this, I get 3 to the third power, a to the third power, and the b squared already had an exponent, so I'm taking b squared and raising it to the third power. All right. So if I evaluate those, 3 to the third power is 27. A cubed is just a cubed. But the b squared, think about it. If you take b squared and you take 3 copies of that, that's b squared times b squared times b squared. That's b to the 6. And we learned that exponent rule as well. When we take a power of a power, we actually multiply the exponents. All right, so that's the rule for what to do when we're taking the power of a product. Okay, so let's say we're taking the power of a quotient. Well, except for the fact that instead of multiplying, we're dividing, it's exactly the same thing. So if I have a over b raised to the nth power, I take the nth power of the a and I take the nth power of the b, and of course they stay in the same part of the fraction they were in before. So again, backing up to the front slide, the example that I had on that front slide of 2 over 3x all raised to the third power, what we're going to do is we're going to take the third power of all three things that are in the parentheses. The 2 is going to get cubed, the 3 is going to get cubed, and the x is going to get cubed. Okay. Now, when it's a number raised to a power, as long as it's not a really large number, like if it was 7 to the 9th, we would probably use a calculator for that, but raising small numbers like 2 and 3 to the third power, multiplying 2 times itself 3 times, that is something we don't need a calculator for. So 2 to the third power is 8, and 3 to the third power is 27, and the x just stays x cubed. Okay, so these are my answers for those initial problems, and that is the rule. So the parentheses here are key. So anything inside the parentheses taken to a power, everything in the parentheses, the coefficients, the variables, even variables that are already raised to a power, everything gets raised to the outside power. Okay, let's go ahead and practice these. Okay, so here are 4 examples. I'll do the first one for you, and then I'd like you to pause the video, and I'd like you to do the next 3 on your own. So 2 times 3 in parentheses to the third power. So first we're going to evaluate, well, this one you can actually cheat on a little bit. I could do this. I could cheat and do the parentheses in the inside first and get 6 and then raise that to the third power. And I believe 6 to the third power is going to come out to be 216. That doesn't really practice the rule we just learned, though. So let's go ahead and use the rule we just did. It'll come out the same thing. So let's take 2 times 3. Both of them are in the parentheses, so let's take 2 to the third power, and let's take 3 to the third power. Sorry. All right, and so 2 to the third power is equal to 8, and 3 to the third power is equal to 27. Those are the same 2 numbers we just saw. And if I multiply 8 times 27, 8 times 7 is 56, carry the 5. 8 times 2 is 16, plus the 5 we just carried will give me 21. And sure enough, I get 216. Okay? So, on the rest of these, make sure that you take anything that's inside the parentheses and raise it to the power. Okay? So pause the video and come back when you've done all 3 of these problems. All right, welcome back. Okay, so you should have done 2 to the 4th power times p to the 4th power, which is almost the answer. That's basically it. All we have to do now is what is 2 to the 4th power? Well, we just saw above that 2 times itself 3 times was 8. So 1 more 2 will give me 16 p to the 4th. Okay, that's what you should have. Check your answers. Okay, the next one is actually a little bit easier. X and y squared both get raised to the 5th power, and you can go ahead and do this in one step. X to the 5th. Now y squared, if I take it to the 5th power, is going to be y to the 10th. Okay, we'll do that in one step this time. And finally, for the last one, and let's do this one in one step too. Both the 5, sorry, that is a 5. It came out a little bit messy. But 5 and the x cubed have to get squared. So 5 squared is going to give us 25. And x cubed squared, multiply the exponents, you get x to the 6. Okay, so this is what you should have for your final answers. So check those against your work. Okay. All right, and let's go on to the next piece. Be really careful with negative signs. Okay, so let's look at the purple problems at the top. When the negative sign is inside the parentheses, what this really means, let's actually write this out. This means negative 5x times negative 5x. And if I multiply those together, negative 5 times negative 5 is a positive 25. Sorry for the interruptions between the dog barking and the phone ringing. All right. Now, on the right side, notice that the negative is not inside the parentheses. Okay, so think about what we just talked about. Only the stuff inside the parentheses gets raised to the power. So first we're going to raise the 5 and the x squared to a power. So that's going to be 25 and x squared. And then I'm going to take that negative that's up front is just going to stay attached to it. Okay, oh, I didn't finish the first one. See, that's what happens when I get interrupted. Okay, so this one, notice, comes out to be negative 25x squared. However, back to the left, the negative 5 and the negative 5 is a positive 25, and the x times the x is x squared. Okay, now the way that I could have done this in one step, using the rule that we just learned, what is getting squared in the left example? Well, both the negative 5 and the x get squared. So negative 5 times itself is positive 25, and x times itself is x squared. Over here, I square just the positive 5 and the positive x, so again, I get 25x squared. The negative is not affected by the exponent at all, so when I'm done with squaring the inside, the negative is still there. Okay? All right, so based on that, go ahead and use the two rules, being careful with the negatives, especially on these first two problems. You'll notice that these are very similar to the ones we just did in purple. And then finally the bottom one. Okay? And again, pause the video and do the 3 problems on the slide, and then come back and we will check your answers. Pause the video now. Okay, this first one, we're taking negative 2y to the 4th power. So negative 2 to the 4th power is going to be negative 2 times negative 2 times negative 2 times negative 2. There's an even number of negatives, so again, just like above, they cancel out, and I get a positive 16. Y to the 4th power is just that, y to the 4th power. So I get a positive 16 y to the 4th. Okay, now on the second problem, again, the negative is outside, so you should have squared the 2y to the 4th. Well, you don't even really have to do much work, because obviously it's going to come out the same thing. It's going to come out 16y to the 4th. Then I multiply by that negative, which is really like multiplying by a negative 1. Okay, and negative 1 times 16y to the 4th gives me a negative 16y to the 4th. Now the third example, we're raising things to the 3rd power. Okay, now in this case, odd powers, it doesn't matter quite as much whether the negative is inside or outside, because think about what's going to happen when I take negative 5 times negative 5 times negative 5. Okay, negative 5 times negative 5 times negative 5. Well, 5 times 5 times 5. 5 times 5 is 25 times 5. Think about quarters. And 5 quarters is $1.25, so that's 125. But this time you have 3 negatives. Okay, and if there's 3 negatives, it's going to come out at negative 125. Okay, the a squared and the b also get raised to the 3rd power, so we get a to the 6th power, and we get b to the 3rd power. All right, so there we go. We should end up with negative 125, a to the 6, b to the 3rd power. Now this bottom one, if that negative sign had actually been out front and we had just taken 5a squared b, positive 5a squared b, and raised it to the 3rd power, we would have actually got the same answer for an odd power, because we would have got the part right here, The 125, a to the 6, b to the third would have been the same, and then it would have put the negative on. So this being careful with the negatives is especially important when we have, well, it's mainly important when we have even powers. Although technically, it is important to keep in mind what we're doing. Okay? All right, so that we got one more thing to do. Let's practice when we have quotients. And so again, I'm making you do a little bit more work on this video just to make sure that we've got this prior to class. So go ahead right now. Remember that everything in the parentheses is going to get raised to the power. And go ahead and solve these, please. All right. So we should be, you should have solved all three problems by pausing the video. So let's go ahead and let's evaluate each of these. So basically what we're doing, we're going to take the quotient and everything inside the parentheses gets raised to the third power. So we get 1 to the third power and we get 2 to the third power. Now you might not have bothered to write that out because 1 to the third power is pretty easy. It's just 1. And 2 to the third power, as we've already seen, is 8. So the first one comes out to be 1/8. Now the second one's a little trickier. Okay, so what we're going to have is we're going to have negative 2 raised to the fourth power. Okay, and because the negative was inside the parentheses, we're going to treat the top as negative 2. Negative 2 to the fourth power is a positive 16. Now the bottom is 3 to the fourth power. And that's a little higher than we've had before. 3 to the fourth power is 3 times 3 times 3 times 3. Well, 3 times 3 is 9, times 3 is 27, times 3 is 81. And another way to think of that, 3 to the fourth power, okay, this is the answer, by the way, but I could have thought of that as, instead of 3 to the fourth, I could have broken that up into 3 squared times 3 squared. And you might think, well, that doesn't seem to make it any easier. Well, if I had done that, 3 squared is 9. So that's actually 9 times 9, and we know that 9 times 9 is 81. So whether you do 4 3s independently or you group them up, either way you're going to get 81. Okay, and the bottom one, let's go ahead and just do this one. So 2 to the third power is equal to 8. X squared to the third power is going to be x to the 6th. Okay, and 3 to the third power, once again, is 27. Okay, and as we do this, I think you can probably see the most common mistake people make, and that is when you take a variable that is already raised to an exponent and we raise it to an exponent, the most common mistake would be to accidentally say x to the 5th power. Okay, and that's not totally wrong. What you're thinking of then is you're thinking of what happens when you have x squared times x cubed. Okay, not when we're raising something to a power. That's when we're supposed to multiply the exponents. If we were multiplying an x squared times an x cubed, this would be x to the 5th. So if that's kind of sticking in your head, that's why. This isn't totally wrong. This is just something different. Okay, this is what happens when you take two different exponents with the same base and you multiply them. Okay, so there's a difference of a product of exponents, which is what this one is, and an exponent of a product, which is what's happening over here on the left. Okay, so if that was a little bit confusing for you, hopefully that will help. All right, well, one last problem, and this is a little bit beyond what's in the textbook, but pay particular attention to the parentheses. So just like we saw with the negatives, if you have numbers and other things outside the parentheses, the power 2 only refers to the stuff that's in here. So we're going to take negative 3 to the second power, so that would be positive 9. X squared to the second power is x to the 4th, and y to the second power is y squared. Okay, that's what I get when I evaluate the parentheses. I still have a negative 2 out front. So the final answer here is negative 18 x to the 4th, y to the 2nd. Okay, whoops. Okay, so pay attention to the parentheses. When we take an exponent to stuff that's in parentheses, whether it's a product or an exponent, we just take everything in the parentheses and we raise it to the power. Okay, hopefully this has been helpful. Thank you for watching, and I will see you hopefully tomorrow in class, and we will practice raising products and quotients to powers. Take care, everybody.